and galaxies. And then he was a postdoc in New Mexico, UCLA. And then later was a postdoc in Max Planck Radio Astronomy in Bonn. Followed by a visiting assistant professor in the University of Nevada, Las Vegas. And since July 93, he joined Nature. And since 94, he is associated with the University of Maryland. And being a senior editor of Nature, you have to deal with hundreds of thousands of papers, and most of them papers that need to be published in astronomy. It's a very hard job for him, especially looking at everyday tests and 100 emails, and the referees and submitting papers. It's a very hard job, selection and filtering and all the stuff he's doing. So, but today he's going to share with us a secret. Really, what you have to do is a guideline for publishing in Nature. So very easy. But we have some experience already, so but I think we are going to learn more from today. So thank you very much for coming.
Thanks, Garrick. So I'd like to come to visit various places to tell people how to get published in Nature. And I like to keep these talks really informal, so if you have questions, or if I'm speaking too fast, or you want me to repeat something, just stick up your hand. The only thing I won't do is debate individual decisions right now. Now, one of the things that you have to remember when you're dealing with nature is that, there it is, we publish only about 7% of what's submitted. The Astrophysical Journal publishes about 88% overall. So it's a totally different experience dealing with nature and the APJ. So what we want is only the best, most important papers, and they need to be written very clearly. And then I'm going to talk about some issues related to publicity, which is very good for our science, but there are issues that you need to be aware of. So Nature obviously is different from the APJ and ANA. And I'm going to keep doing this. Where's my arrow? I'm going to keep repeating this number because it's very important that you bear that in mind. We publish a very tiny fraction of what's submitted. We get about 15,000 papers submitted a year, and we publish about 1,000. We're strictly independent of all the science societies. All we care about is publishing the best science. We don't care who you are. We don't care where you're from. If you're an unknown graduate student doing great work, we'll publish it. If you're a big shot who's trying to push something that's really not very good on us, we'll just say no. We're not going to publish it. We have the independence to be able to do that. Now, obviously, Nature is different from other journals, and dealing with us can be kind of a hassle. The format is kind of screwy for astronomers. The style of references and the layout of the paper is basically dictated by what is standard in molecular biology. So as astronomers, we're about 10% of the population of physicists. Well, physicists number about 10% of the total number of biologists. So roughly speaking, we're about 1% of the world scientific community. So what we want to happen and the styles we like are just not going to happen in Nature. We're dominated by biology. Now, there are some specific reasons why it's good to want to publish your paper in Nature. Skip ahead. In general, because we try and pick the most important papers, generally, when a paper is published in Nature, your colleagues take notice, and especially for young people, it can give you the kind of name recognition that could give you an edge when you're applying for jobs. Most university departments, you'll be lucky if there's one other person who will know about you through your own work. But if you're published in Nature, your paper's going to be known a bit more widely. Now, a couple of times a year, I can take in a paper and publish it in about a month, from submission to in print. We did that with the first gamma-ray burst, optical counterpart of a gamma-ray burst. We've done it with a few other things, the Hubble Space Telescope Key Project result. Curiously, when production was all paper-based, we could actually go faster than we can now when everything's electronic. It has to do with time zones and copy editing being done in India and things like that. But we can still do it in about a month. We can also offer you very wide publicity. Now, individual scientists often don't care about this very much, but observatory directors care about it a lot because that gives them leverage to go and argue to the government that we need more money because we're being very successful. Now, this is how most scientific papers are made. So you start with sparse and infrequent observations, you've got errors, theoretical misunderstanding, controversy, confusion. Finally, you get coincidental agreement between theory and observation, and you write a paper. Now, that's not what we want in a Nature paper. So this is what we look for. We want a paper that reports a fundamental new physical insight or reports something that's startling, completely unexpected, even if you can't explain it. I mean, one of the great, some of my favorite Nature papers are ones where there was just no theoretical expectation for this result. It just totally came out of the blue, and the authors couldn't understand it, and they just said, this is what we see. And often people will get a result like that, and then they'll try and come up with an explanation, or they'll wait until they can come up with an explanation to submit the paper, and then the referees say, well, that explanation doesn't work, and then they get upset. But some of my favorite Nature papers have been ones where there was just no explanation. And to make this specific, there was a graduate student a number of years ago at MIT who found for his thesis that asteroids either rotated very quickly prograde or very slowly retrograde. And it was just a bimodal distribution. There was no continuum. So why? And we just published the paper, and then it turned out a couple of years later that this was being driven by the Yarkovsky effect, which is sunlight on the sunlight and re-radiation on the asteroids, and it drives them to those two states. So nobody would have investigated it if the weird observation hadn't been there. In some way, a Nature paper has to be of importance to people in your field. Think of it, every year as we look back on progress in our own area, there was always one or two, maybe three papers that stand out in your memory. Those were the ones that really pushed the field forward or changed the direction of the field. Those are the papers that we want to publish, and everything else can go somewhere else. So whenever you're considering submitting a paper to Nature, do that internal calibration. Compare it to everything else that's been published in your field over the last couple of years and say, where does it fit in the continuum? Now, here's a topic on which I get into a lot of discussion with authors. We reject most papers, about 3/4, without going to referees. And some authors get upset about this. But the simple fact is that, I handle about 500 papers myself each year. And to calibrate that, there are 2,000 papers, give or take, submitted to the Astrophysical Journal each year. So personally, I handle 1/4 of the entire load of the Astrophysical Journal. The only way to stay sane is to get rid of all the papers that, even if they're right, they're just not very interesting. So we try to filter those out and send the remainder to referees. The filtering is sometimes done by myself on my own knowledge or background reading. Sometimes it's done by sending an email to somebody in the field. You know, I've done this with Garrett. And, hey, I've got this paper. It says this. What do you think? Is it sufficiently interesting to go to referees? And sometimes they'll come back and say no. Sometimes they'll come back and say yes. And so I send out about a quarter of the papers that are submitted to me. And then of that quarter, about half of those will end up getting published. So in astronomy, the publication success rate is somewhere around 12%. It's a bit of small number statistics. It fluctuates a bit from year to year. Now, here's another topic on which I have some disagreements with some authors. Disagreements can be sometimes vocal. I once had a shouting match with an author at a AAS meeting who said, my paper should only be comprehensible to 6 other people in the world. And I said, fine, take it somewhere else. Because if the paper can only be read by a few other people, then it's a waste of my page space. Nature doesn't charge page charges. Instead, every year we get a budget, a page budget for management. They project we'll have this much income, and therefore we can afford to publish this many pages. And normally, so if you take the budget and divide by the number of pages, it's something like $25,000 for a page of Nature. And so what we try to do is only pick the very best papers so that we're not wasting space. And if a paper is incomprehensible, it is a waste of space. And I just don't want it. And people will sometimes ask me, well, my English is not so good. Don't worry about that. We clean up the English. That's not a big deal. As long as the scientific point is important enough and clear enough, we'll fix the paper. 2 of the very worst papers I have ever published came from native English speakers at major British universities. You can name the 2. And they were terrible papers. They managed to get through the referees, but I use those 2 papers if I'm teaching a grad class about how to write a paper. I will use these as examples of what not to do. So the targets that I tell people to aim for are, there we go. The first paragraph, which is not an abstract, but it's in boldface, should be no higher than the level of an introductory undergraduate class. And so why do I pick that level? Think about how scientists diverge. In first-year university, we'll take a distribution of courses. After that, the physicists will specialize this way, the chemists will go that way, and the biologists will go that way. So what you want to do is reach back to the level that all scientists have in common, which is usually about first-year university, and try and convey the big picture at that level. And then the bulk of the paper should be about at the level of a first-year graduate class in the field. And that's the same reasoning again. So, everybody takes interstellar medium class as graduate students. And usually Jackson, electrodynamics, or something comparable. So what you want to do is reach back to that level so you can communicate to all physicists and astronomers. Now, inevitably, there are going to be components of the paper that will be very specialized. But what we try to do is minimize that, and so that you're talking to everybody. You're communicating your result to everybody. And so I like to say this, if the paper isn't comprehensible, why bother publishing in the Nature? It's just, there's no point to it. Now, as scientists, we receive no training in how to write a scientific paper. As graduate students, we start reading the literature, and because most papers are badly written, we use those as examples, and then we write badly. And this is illustrated by a cartoon. I don't know if you ever had this in Spain, but Calvin and Hobbes. So Calvin is a 6-year-old, and he's got a stuffed tiger who comes alive when they're alone. And then whenever a grown-up is around, then the tiger reverts to being a stuffed tiger. So Calvin says, I used to hate writing assignments, but now I enjoy them. I realized that the purpose of writing is to inflate weak ideas, obscure poor reasoning, and inhibit clarity. With a little practice, writing can be an intimidating and impenetrable fog. Want to see my book report? The Dynamics of Interbeing and Monological Imperatives in Dick and Jane, a study in psychic transrelational gender modes. Academia, here I come. So for those of you who don't know, in North America, we learn to read from the Dick and Jane books. See Dick run, see Jane run. So those are generically referred to as the Dick and Jane books. The key to writing a good Nature paper, or a good paper anywhere, is actually pretty straightforward. This is the secret, okay? First of all, you have to tell people why the topic is interesting, okay? What's recently been done in the field? What's the context within which the work is set? What problems are there that haven't been solved by the recent work? What have you done? And how does this advance us toward a solution of one of the big problems? And it's as simple as that. And I have found that now when I write APJ papers, I use this formula, and I like my papers a lot better than, when I first started writing APJ papers. Now, so this came from a calendar of stupid sayings that my wife got me quite a while ago. Of course, for much of the last decade, such calendars have been dominated by the sayings of George W. Bush, but this was prior to that. Rookheiser's frequent use of terms like truth and meaning gives these essays a pre-postmodern tone, yet they remain remarkably relevant, perhaps because she does not define the content of truth or the meaning of meaning. So that's pop psychobabble, right? And often I will deal with papers that use what I call pop astrobabble. And this amazing result came about because of our unique instrument with its world-class capabilities. You shouldn't use those kinds of adjectives in a Nature paper. If you're going to submit a Nature paper, you say in very straightforward terms, this is what I did, this is what it means. You don't try and sell it to me. In fact, that usually turns me off more than anything else. Now, anyone who's dealt with NASA missions will recognize, or ESA missions will recognize this. Calvin says, I like to verb words. I take nouns and adjectives and use them as verbs. Remember when access was a thing? Now it's something you do. It got verbed. Verbing weirds language. And Hobbes reflects that maybe we can eventually make language a complete impediment to understanding. Now, I'm going to talk about publicity for a bit, and then I'm going to move on and talk about some ethics issues. Publicity and ethics are interrelated. Now, it has always been allowed to post to AstroPH at any time, at an author's convenience, before you submit a paper to Nature, during review, after acceptance, whatever. It's up to the author. But if you post something to AstroPH, it is legally published. Now, we ignore that, and The APJ ignores it, and ANA ignores it. But in fact, it is legally published, and it is public domain, and any journalist can write whatever they want about it. If you post to AstroPH and put in the notes field, submitted Nature, within 3 days, Sky and Telescope will probably have something on their website about it. And then New Scientist will pick it up, Science News. It'll kind of trickle out. By the time the Nature paper comes out, the big guys, CNN, BBC, New York Times, they'll look at it and say, old news, and they won't cover it. So the individual scientists mostly don't care about this, but observatory directors and university deans care about it a lot. So if you're considering submitting a paper to Nature, the first thing you do is go and talk to your local public affairs people, and if you've used a telescope that's not from your facility, Spitzer, HST, Chandra, VLT, whatever, make sure you talk to the public affairs people for the observatory before you do anything else. Because observatory directors can get really mad when they see a result coming from their facility and it doesn't get any publicity just because the astronomer posted the work and it trickled out. But the publicity really is important for us. Astronomy on a per-scientist basis is the most generously funded science in the world, hands down, by a long way. You know, we've got multi-billion-dollar facilities, and, you know, we ask for them and we generally get them. There are 10,000 astronomers in the world. And we need to be able to justify to the governments and to the general public why they're investing this kind of money in us. So publicity is really, really important for our field, for the health of our field. And we want to inspire the next generation of astronomers who are coming along. You know, I became an astronomer, as did a lot of people of my vintage, because of Apollo and Star Trek, right? So, you know, that we need to inspire, keep people coming. Now, did I skip? Yes, Yep, okay. Okay. I skipped ahead a couple pages. Now, a few years ago, I was invited to a theory conference and to speak to them about why Nature publishes so little theory in astronomy and across the board. We publish very little theory. And this is a result of a very deliberate decision that was taken about 25 years ago by the current editor-in-chief, who was doing my job at that time. And we were getting a lot of papers that, you know, as Planck used to say, they were not even wrong. They were exploring some little region of parameter space that nobody cared about. John Cormandy once described them to me as wonky theory papers. He said that when he was a graduate student, he could safely ignore the astronomy in Nature. And we took this decision to focus on observational and experimental results. And so within the space of a decade, we went from having 2% of the most highly cited astronomy papers to over 20%. And we're not going to go back. So even now, the theory papers that we do get through, some of them are said to be lightweight. And there are some reasons for that. People say, well, we don't allow enough space. That's not really true anymore because we have the online supplementary information. But the real problem that we have, and I've talked about this with Rob Kennicott, when he was editor-in-chief of the APJ and other astronomy editors. Theorists tend to be what we call soft as a referee. There is a school of thought that everything should be published. You know, no matter how bad or how wrong, it should be out there. This is a defensible position for a society journal, but not everything needs to be published in Nature. And so we really try to limit the theory that we get. So this old quote from Fred Hoyle really puts the finger on the difficulty we have. That if a theorist is right more than 5% of the time, he isn't trying hard enough. And that's the problem. We want stuff that is both important and right. And a lot of theory is designed to mix things up, try crazy ideas, see what works. Obviously, when you're operating in that mode, most of the stuff isn't going to work, as Fred Hoyle observed. And, you know, we just have difficulty dealing with those kinds of papers. So, you know, if an idea is really wacky, arXiv is the best place for it, and just start a discussion on arXiv. So what we specifically look for in a theory paper is we want authors to defend the position that their paper is putting forward the right explanation, or at least the best explanation at the current time. I mean, obviously, things evolve, and something that's regarded as correct now, 20 years from now, might be seen as totally wrong. That's science. That's the way things work. We like models to make a prediction, a specific prediction that could be checked within the next couple of years to give some immediacy. And the prediction should be sufficiently central to the model that if the predicted behavior is not seen, then the model cannot be right. Now, sometimes you just can't do that. But, you know, if you can, it gives some immediacy to the paper. And, okay, here's the preprint server policy. This is the formal statement. It's always been allowed. When I joined Nature, I went to the wall to make this happen. And it's always been allowed. And I get really annoyed when people say, oh, well, I didn't submit my paper to Nature because then I couldn't post it to AstroPH. I hear this all the time, and it's complete nonsense. But this is how the preprint servers complicate our lives. So as I said, posting is publication. I mean, there's just no two ways about it. You cannot post and say under embargo at Nature, because it is not under embargo. Putting the words there is completely meaningless. It makes you look foolish to journalists because you don't understand what you're doing. There is no embargo any longer once it's posted to AstroPH. Now, this point about science by press release. This happens all the time in biomedical. Okay, somebody does a poorly constrained study with small number statistics, and they find out that Coke causes cancer. And then 3 weeks later, no, Coke cures cancer. And this happens all the time. And it just turns it into noise. You don't believe any of this stuff anymore. So we don't want our field to fall into that trap. Peer review is our quality control, and for all its faults, that's how we try and make sure that the best science gets out. So I had a little interview earlier, and Garrick asked me about peer review. And I said, well, my take on peer review is just like Churchill's take on democracy. It's the worst possible system imaginable, except for all the others. And that's how I look at peer review. It doesn't always work, but mostly it does. And it Sometimes it's messy, but it's the best way that we have evolved to control our science. So you shouldn't be publicizing to journalists, issuing press releases before the peer review process is complete. And then the completion is the publication. So that's our take on embargo. Now, how many of you have heard of the sad case out of Bell Labs about 10 years ago of Jan Hendrik Schoen? Nobody? Yeah? So he was a condensed matter theorist, condensed matter experimentalist, working at Bell Labs, and he was a postdoc, and he had a series of papers where he was able to dope electromagnetically samples of materials. Now, when you dope chemically, you're putting atoms in the lattice, and you never know if you're changing the electronic properties because of the electronic structure of the dopant atoms, or because you're changing the crystal lattice in which the atoms are embedded. So being able to tune the doping electromagnetically was a big deal. So he had a string of really high-profile papers over the space of a couple of years. It looked like he was on fast track to a Nobel Prize. And Princeton University, this is how the world really works. Princeton University had offered an endowed chair to a woman who was quite senior, and they withdrew that offer and offered the chair instead to Schoen. So the lady for whom the offer was withdrawn, she made it her mission in life to bring down Schoen. And so she went through all of his papers and found out that the data were all faked. There was not a single valid data point in all of these publications. And Bell Labs tried to hush it up, but it all fell apart in the end. And he was fired, and he was German, and his university actually stripped him of his PhD, which I always thought was a little bit mean-spirited, but fraud at that level is very, very rare in science, at least in the physical sciences. And it's incredibly rare in astronomy because so much of our data is in the public domain. If somebody has an HST paper and they submit it to me, often my referees will go to the HST archive, download the data, reduce it themselves to convince themselves that the result is correct. I mean, you have to be really, really stupid to fake your data. Because if the result is sufficiently important, there is going to be a graduate student or a postdoc out there who is going to try and make his name by proving you wrong. The more important the claim is, the more people are going to be gunning for you to show that it's wrong. And so just don't fake your data. But there's a lot of unethical behavior that goes on that is, while perceived of as lower level unethical, in fact constitutes the bulk of the problem. Now, in astronomy, I am seeing at the 20% level, people will submit a paper to me, and this amazing result, and never been seen before, and I'll do an ADS search on their name for the last couple of years, and they've got 3 papers out there with basically the same result. They may have added a bit of new data, they may have changed the words a bit. And these earlier papers are not cited in the Nature paper. That is deeply unethical, and it's so easy to catch. I mean, I do this ADS search on every paper. And I'll also do keyword searches to see if you've neglected to cite other people who are working on the same topic. And so I have a standard wording for rejection letters when I come across this. And I'll say, this seems to be not a significant advance in understanding relative to give the references, which, curiously, are not cited by you, just to let people know they've been caught. So don't do that either, especially not with me, because I do this ADS search all the time. John Scalo and Chris Needon do the exact same thing at the AppJ letters, so don't pull it on them either. Now, this is a particularly striking number. 30% of biomedical people admitted in the survey to engaging in unethical behavior. And because of that, some of the medical and biology societies actually lobbied against a systematic survey to study how widespread unethical behavior was. I mean, even though I'm Canadian, I live in the States now, and we're seeing the same kind of crazy behavior. The banks who brought us financial crisis are lobbying against the regulation that would prevent a future crisis. It's crazy, but that's the way life is. So what I advocate is don't let minor ethical lapses go unremarked. Make sure students understand what the limits are, how you're supposed to behave. The AAS released recently a guideline for ethical behavior. Make sure you read that, and that's a good starting point. So, So I was invited to speak to the Conference of Scientific Society Executive Officers a number of years ago about ethics in science, and I did quite a bit of research for this talk. And including talking to my department chair at Maryland, and who's not the current chair. And I said to him, okay, if somebody discovered unethical behavior of one of the members in your department, what would you want to happen? And he said, don't talk to me. I don't want to hear about it. And that's exactly the wrong attitude. I mean, we have to be open to this. We have to discuss it. We have to make sure that people know what's unethical. And as a result of all this research, I came to the conclusion that anything that removes transparency is unethical. There is some need for anonymity in peer review. Some of us, myself and David Branch and a few other notable people, always sign the reports. Other people never sign them. Some people, it's in between. Nature actually encourages people to identify themselves, but if it's a young person, especially writing a negative report on a senior person, that's why anonymity is there. I'll tell you, the absolute best referees are are postdocs who've been out 2 to 5 years, and they've been in the field long enough that they have some seasoning, they know the field intimately, and they're still politically naive enough to tell the truth. And then I'd like to illustrate the don't shoot the messenger with this Dilbert cartoon. So be candid, Dilbert. We have a corporate philosophy that says we don't shoot the messenger. Good. Had you consulted with the engineering department, you never would have launched such an ill-conceived product. It is doomed to fail. You will all be humiliated and probably fired. Can't I just wing him? No, Eileen, that's not our philosophy. And there he is, tar and feathered. Turns out the corporate philosophy is a very flexible document. So don't shoot the messenger if somebody comes to you with an ethical problem. Now, as tough as I can be to deal with as an editor, and I can be pretty tough, I'm always going to squeeze you on the length. I'm always going to be pressing you to explain more clearly why this is important. But one of the things that I love to do in my job is help. And there are many ways I can do that. So how many of you have heard of Mount Graham, the large binocular telescope on Mount Graham in Arizona? Yeah, on the red squirrels? So back in 1989, when I moved to Bonn, I became friends with Peter Stripmatter, who used to spend a lot of time there because the MPIFR was building a telescope on Mount Graham, or wanted to. And Peter regaled me with these stories about what the biologists were doing to manipulate and invent data about the red squirrels. And Peter could never get his side of the story out. So when I joined Nature, I invited him to write a commentary for us, saying, you know, this is what we've done, this is what these guys are doing. And so what the wildlife biologists were doing was only counting squirrels right exactly where the astronomers wanted to put the telescopes. They weren't doing a survey of squirrels on the mountain, which is what was needed. They were only counting within the footprint of the telescopes. And they would say, oh, gee, you know, there's only 20 squirrels on the mountain. It's nonsense. I mean, there are thousands of them. And so I was able to help him get his story out, and that was what helped to break the logjam and get the project going. Another incident, I was talking to a colleague at Maryland on Saturday afternoon. I was working on a paper and ran into him in the hall. And he was grumbling that he had been given a NASA grant 16 months earlier. He'd already written his first annual report, and he still didn't have the money. And he'd had to borrow $250,000 from the department to keep the program running. So I said, this sounds like a story. So I went in Monday morning and talked to one of the journalists, and they said, oh, yes. And they got on, and they started making calls, and this was a widespread problem. So then he called NASA headquarters, using my colleague's name in particular. 3 days later, he had his grant money. So don't underestimate what we can do to help. That's the power of the press, right? Talk to me. If you see me at a conference, if you're coming through Washington, send me an email, and we can have dinner or have lunch. If you're going through London, send me an email, because I might be in London. I typically spend about 6 weeks out of the year in London. And or if we can't meet up, just send me an email or pick up the phone, call me. I answer my own phone. I answer my own email. And mostly, I try to answer emails within about 10 minutes. I can't always do it. You know, there are times when I'm giving talks like this. I'm traveling, and I can't. But if I'm sitting at my desk, my goal is to answer most emails within about 10 minutes. And as Garrick knows, that's about what I do. And so contact me. And here are the points to remember. And then to tell you how serious I am about contacting me. So there's my email address and my direct phone line. And I answer my own phone. The only time my admin assistant answers it is if I'm not in the office. And even if you're a difficult person or you want to complain, I still talk to you, because that's the best way to do it is to deal with such things promptly. The longer you put off dealing with the problem, the worse it gets. There was only one time I ever was dodging a person, and I didn't even know I was dodging them. So I got this 2 crank papers submitted. Oh, you guys should ask me about my cranks. I've got some great stories. But these were 2 papers submitted about the face on Mars. And, you know, obviously I rejected them. And then my admin assistant is really good at filtering out who's serious and who isn't. And the lady I had at the time, she fielded a call from him the day after I had rejected the papers, and she didn't even tell me about it. And then, so he called every day for 6 weeks, and I didn't even know about it. And I happened to be walking by your desk one day, and I caught one of these conversations, and she was saying, oh, yes, Dr. Sage is very busy, has lots of meetings, which I actually don't. But so I asked her what was going on, and she told me, and I said, okay, this has got to stop. So the following day, I told her to put him through to me, and so he asked if I could explain in a bit more detail why I wouldn't consider his papers. And I said, it's crank science. And he was very calm, and he said, well, you know, other people have told me that. But there really is a conspiracy at JPL. And I said, if there's a conspiracy, I'm sure the National Enquirer would like to read about, like to hear from you. And so, you know, I just had to put a stop to this. And, so anyway, that's it. Do you have any questions for me?
In case of conflict, would you favor to publishing both a paper and a negative referee report?
I have overruled referees, and we don't publish the reports. I think that we should. I think we should put all reports online. You know, if you go through 2 or 3 rounds of review, I think everything should be available online so anybody can see why the decision was made. Nature has not reached that point yet, but I think that's what we should do.
I don't really know how to say this in a politically correct way, but it's not, I mean, as an author, it's not clear to me how do you decide that this paper is good or is not good enough. Often you see things in nature that as an expert you judge it not to be good enough. And on the other hand, I mean, you know some other things that never make it through. So could you try to elaborate a little bit more on that?
Okay. So the way it really works is the top 2% and the bottom 50% are immediately obvious. Okay, I read the abstract, and this is a terrific paper. This is boring. So most of my time is devoted to the stuff in between. And that's where things get messy and complicated. So you send papers out to referees who, based on their research, ought to be expert in the field. They're highly cited in the field. Maybe they're going through a divorce. Maybe they've got a sick kid. These things happen. We try to control for it as best we can, but science is a human behavior, and we have weaknesses. And that's why some papers get through and others don't. When I come back from a trip,
Let me ask this in a slightly different way. What is the percentage of the of the paper in astrophysics published in Nature by an unknown group of people, basically people that is not, you know, part of the mainstream or something like that?
Probably 10-15%, and I wish it were higher, and that's why you know, to be honest, it's not a useful. It's not good use of my time for me to go to the CFA and tell them about publishing Nature, or go to Caltech, because they're going to submit to me anyway. The best use of my time is to go to smaller departments, and then people get to know me as a person, and they'll feel more comfortable submitting a paper. Years ago, I visited ESO, and we were just sitting around at coffee time, and somebody asked me, why don't you publish any stellar astronomy? And I said, why don't you submit any? we won't get any stellar astronomy submissions. And they said, oh, you want it? And I said, yeah, if it's really good stellar astronomy, send it. And some of my best papers have come from graduate students who I've never heard of before. So, you know, when I assess a paper, I completely ignore who the person is or where they're from. You know, I don't care if it's Joe Silk and he's submitted something that's really bad. You know, it's just bad science. I'm going to get rid of it. And if it's a great paper from an unknown graduate student, out it goes to referees. I mean, I truly do not care. There is no bias. We try to remove the language bias as much as possible. As long as the point of science is comprehensible in the paper, we will deal with the English afterwards. So.
Is very, very good, but I think that's mostly driven by biomedical sciences. Do you have any impact factors specifically for astronomy that we can directly compare with?
Okay, so in the first 2 years after a Nature Astronomy paper is published, the average paper will get about 30 citations per year. So, you know, roughly speaking, that's a measure of our impact in astronomy. Recently, we have tried to cut the tail. You know, there's a long tail of papers that don't get many citations. Those are dominated by solar physics and meteorites. And so we have made a conscious decision that we don't want to stop publishing such papers, but the editorial barrier for consideration is now way higher than it used to be. Planetary dynamics is kind of a hit and miss area, and so is space physics. So, you know, those papers get extra scrutiny. But gamma ray burst papers, for example, you know, they could get 100 citations in their first year.
I have the impression, maybe the wrong impression, that to submit a paper to Nature, you need to have the solution.
No.
Right?
No.
I don't read many papers in Nature like in any other magazine that you say, well, this is a probable solution, or can be this, or can be this. Right? And sometimes myself say, well, I will not submit this to Nature because I don't have the 100% solution. This is a possibility, but maybe it is another way. And to be honest, also people that used to publish in Nature say, oh, you need to say that's the solution.
No.
It's from Nature. You have to be sure that that's correct.
There's so many myths out there about Nature, which is why I go out and give these talks. You do not have to have the solution. If it's a striking result and nobody knows why it's that way, that's a great Nature paper.
It's sufficient to say that you have this possibility and that's it?
If the result is sufficiently striking, okay, there are shades of gray here. The asteroid story I told you was a classic example of the original version of the paper. The author thought he had to have a solution, and he had pages and pages of nonsense. And the referee said, "That's nonsense. Take it out. It's a great result. We don't know why it's doing that." And that's a great Nature paper. So you absolutely do not have to have an explanation, as long as the result itself is sufficiently striking.
Another tricky question. When you have a good paper that you want to submit, how to decide if to send it to Nature or to Science?
Science has the same goals as us, and how well each accomplishes them is left as an exercise for the reader. By the way, I strongly encourage people to send me an email before they even start writing a paper. Just say, hey, I've got this result. Do you think it's potentially nature-worthy? And I have several paths I can take. I can say, obviously, yes. And then I can say, obviously, no. And sometimes I'll say, can't tell. I'm going to have to wait until I see the manuscript. But it's always worth contacting me even before you start writing the paper. And I don't care if you want to format the paper as APJ letters. That's fine by me. If it passes the editorial barrier and the referees like it and recommend publication, we can sort out the format later. And if it doesn't make it, then there's no time wasted in reformatting.
Filters and fields based on citations. Is that driven by financial considerations, or is it related? One would imagine that the size of the community has an influence on the citation rate.
Yes, the size of the community does have some effect, but the decision is sort of related to finances, because what we can charge for advertising in Nature depends upon our impact factor. If we're publishing in fields that nobody really cares about, and it's diluting our impact factor, then it's hurting us financially, and it means that we can publish fewer good papers that people care about. So, it's partly financial and partly pragmatic. 50 years ago, solar physics was cutting-edge astronomy. It isn't anymore. The astronomy's moved on. It's just like meteorites used to be cutting-edge planetary science. They aren't anymore. We've moved on. So, it's just recognizing that fact and moving the journal on.
Is there a sort of a major decision-making body, maybe within Nature or external, that makes these kind of strategic decisions?
No, it's not external. We don't have an external advisory board. These decisions are done, are made within each team at Nature. So we have a team of 15 biology editors and 10 physical science editors. And about once a year, we get together and we talk about these issues. And, what we'll do is we'll have the data in front of us for the last 2 or 3 years. Here's what we published, and here's how the citation patterns are going. Like I said, we don't want to cut off those fields, but if you're considering sending us a solar physics paper, I'm going to want to know specifically why you think this is the best solar physics paper for the last 3 years. Okay? No. I published a...
But if someone wants to publish in these areas, it should be an extremely important paper, not like in others.
Yeah, well, like we just published a meteorite paper about 9 months ago. The one that was caught as a bolide coming in by the Catalina Observatory, and then they recovered a bunch of fragments in the Sudan. And okay, that's
an extraordinary.
Yeah, that's right. And so.
In some other fields, you can read some Nature paper that says this is something that will appear in many other medicines. That's important, or even less important. Most of the papers are reading in Astrophysics, for example.
Yeah.
So the community should know that, because then people is evaluated, people of different fields. A solar physicist will be evaluated with a person that works in galaxies or planetary system that can publish easily or more
easily. Mm-hmm.
So I think that you should clarify that in your medicine. So when when referees or when people that evaluate persons know that, can say, okay, this is a good astronomer because published in Nature. This is not good because that's don't publish in Nature, but this is a solar physicist. So
well, whenever I send a paper out to referees, as Garrett knows, I will almost always put in, why do you think this paper is one of the most important papers in the field of the last year or so? And the referees, if they don't come back with a cogent explanation of why, then I will email them, and I'll keep pressing. Okay, you're recommending publication in Nature, but why? And, that's the best we can do. Sometimes the referee will have his or her own agenda and recommend publication when it may not be appropriate in the eyes of the other people in the field. I can't control for that. I do the best I can. Mm-hmm.
Data is public, suppose HST data or whatever. Download and use. If you have a theory paper which is based on models, and especially if the models are not public, suppose somebody is doing evolution research, and the model is not available, and he never published them, he's not going to publish them now, and he will not publish them in the future. So none of the referees, none of the historians have to check those results, because he has a model in his pocket. In his own computer, he's the only person on this planet who controls the model. So what happens? Because we have situations like that.
Right. So in a situation like that, it depends upon the referees. And if the referees sign off on the paper, it gets published. If the referees say, well, I really need to know more about what's in the model, then if the author doesn't provide that information, the paper doesn't get published. So it's up to the referees at that point. What we try to do is, as editors, is say, this paper is sufficiently interesting. We leave it to the referees to tell us whether it's technically correct. Now, and there's a very strong culture amongst editors in staying out of technical arguments. The reason for that goes back to Chandrasekhar when he was editor of the APJ. And, he took against Zwicky. And he didn't want to publish anything about interacting galaxies or wacky rotation curves. Now, Chandrasekhar is way, way smarter than I am. And he held back that field for a long time. So amongst the astronomy editors, and, we talk all the time. We meet at conferences and exchange emails. I try to make sure that as much as possible, my policies for astronomy and nature are completely in line with general practice in APJ, AJ, and ANA. And there's this very strong culture that we don't get involved in technical arguments. We can make a decision up or down based upon the advice of the referee, but we don't get involved in the technical stuff ourselves.
Mm-hmm. I'd like to point out that something in the paper went through fairly smoothly. That was my experience, it was accepted. Then the major headline from my point of view was that they had to cut it down quite seriously, about two-thirds of the length. And then one frustration I had when I got just this morning the printed version was
there's a bit of
there's a lot of white space. All the 5 articles before and afterwards have a 3/4 page of white space. So why are you so insistent on cutting down? I think in this case, if you even cut down, I think almost you could have said.
Okay, this is a frustration that the editors have with the production department too. We made the shift about 4 years ago to new page starts for all papers instead of running them one after another. And so the fundamental issue is if I let every paper go 10% over the page limit, then over the word limit, at the end of the year, then I can publish 10% fewer papers. So I hit November, and I'm, not being able to publish astronomy. So I am always going to be pushing authors to go shorter.
But I think they should then make a bit better effort to estimate the true number of pages it will be. So you don't have to get 3¼ pages or something.
I know.
So you either get 3 pages or then you check out it doesn't complete. So let's give the guy 300 words more so we can fill it out.
The problem is that page layout is done individually all the time by the production department, and they make decisions on the fly about what size to make the figures and how to place them in the text, and those decisions are always made after the paper is accepted. There's just no mechanism for us to be able to guess the layout. I wish there was, but...
The thing one is in your editorial assessment, but you have a guess on the four figures and the table you have 750 words. Not 1,500, 750. That's what you need to be worth about the gadget.
Yeah. It's frustrating for me too, but that's the parameter space that I can work in.
To be often in science a bit of a trade-off between how groundbreaking the result is and how well established the foundations are. Sometimes I perceive a bit of a conflict between editors and referees regarding where exactly the paper has to stand that trade-off. I get the impression that in Nature you're trying to publish something that's really groundbreaking. So sometimes you have to be you have to take it a bit easier on I'm complaining about referees sometimes being a bit overzealous.
Okay. Let's illustrate this with a specific example of which I have intimate knowledge. Michel Mayor's Planet Around 51 Peg. So here I am in summer of '95, and this paper gets submitted. For 15, 20 years, there have been claims of discoveries of planets, and every single one was false. Every single claim was false. So that was where we started with Michel. And obviously, it was very important if correct. So I sent it out to 3 skeptical referees, one of whom was specifically charged with physically, can this planet exist? Would it have evaporated, given a reasonable estimate of the age of the star? And it turned out that the referee I had picked had already been contacted earlier by Michel, because Michel had this question in his own mind, and he wanted the answer before he even submitted the paper. And so the paper went out to the referees, and they had the standard worries: is it a stellar oscillation? Could it survive? A few other things, but it all looked very promising. And so I wrote to Michel, and he'd submitted as a letter, and I said, Michel, if you can convince the referees, we're going to make this an article, the longer version, and there is no page limit to you. You can have whatever space it takes to convince the referees. And he came back, and it was still a relatively modest-sized paper. The referees were happy, and the paper was published, and it was right. And a whole new field was born. So, there are 2 things that I bear in mind. John Bacall always said a 3 sigma result is wrong about half the time. And throughout my career, I've observed that to be true. So if somebody submits a 3 sigma result to me, I will immediately have in mind that there's a 50-50 chance this paper's wrong. And that's just the way it is. So the way I look at it is if it takes 2 years of hard work and a lot of effort by people to prove the paper wrong, that's fine. That's the way science works. Then we move on. If it's shown to be trivially wrong 6 weeks after publication, then I'm as mad at the referees as I am at the author. So, and the other point to bear in mind is the classic quote from Carl Sagan, that extraordinary claims require extraordinary proof. So every time I pick up a new manuscript, I have that advice right in the front of my mind. A 3 sigma result is wrong half the time, and extraordinary claims require extraordinary proof. So does that answer for you?